Okay, hey Algebra 2, welcome to lesson 46 and 47. If you look at lesson 46, it is not hard, but it is tedious, we like to say. So that means that it just takes a while, that's all. It's not hard at all, it's just annoying sometimes, okay? So, and then lesson 47 is super easy, especially the very first part, and then the second part is basically the same as lesson 46, just one more step, okay? So if you just focus in on the steps that I'm doing, then we should be good to go on this lesson. Look, these problems right here, it says on examples, all the examples we're going to do, it just says to simplify this. And the reason why you have to simplify it is if you look at it, you cannot have these fractions with the square roots, because that means that this square root applies to both the numerator and denominator. And remember our rule about square roots, you can't have a square root in the denominator. It can't be simplified that way. Then over here, we already know that this has to be simplified. We have to take things out of it. Okay, so what I do when I write these down, I wrote it down like this to show it to you, but really I write it down from my book like this, because that helps me see what square root I need to get rid of, okay? Remember, the square root you need to get rid of is the one on the bottom. So remember what I taught you before in the one lesson about rationalizing denominators? What do you need to do to get this square root off the bottom? You need to multiply the whole thing, this whole fraction, by square root 2 over square root 2, because that's your denominator, okay? So that's what you're going to have to do for this one. And then over here, you're going to have to multiply by square root 5, square root 5. So I try to save myself a little bit of room so that I can simplify those quickly. So what are we going to have then? We have 3 square root 10, because 5 times 2 is 10. And then what do we have on the bottom? We just have 2. Because remember, it's 2 times 2 is 4, square root of 4 is 2, so it always just cancels this out and makes it just 2. Plus 3 times, and even though, remember, even though this 3 is on the whole thing, it's applied to the numerator. So I just put it on the numerator right here. 2 times 5 is 10. Square root 5, square root times square root 5 is going to give you square root 5. Just 5 on the denominator. And then minus, what can we take out of this one? What perfect square can we take out of it? A 9. The square root of 9 is 3. So we're going to have 3 square root 10, right? Now everything is looking good on the top for us to be able to combine these together. The problem is our denominators aren't the same, right? So we need to now write this with common denominators. Well, our common denominator between 2 and 5 is going to be what? 10, right? So I'm going to make this a 10. 2 times what equals 10, which is 5. So I'm going to multiply this one up here by 5, which is 15. Okay? And if you're like, Miss Jessica, what in the world did you just do? Remember, it's just 3, 2 is what you had right here. You need to make the common denominator 10. 2 times 5 is 10, so 3 times 5 is 15. So I just changed it right here instead of writing it all again. Same thing here. This needs to become 10, so 5 times 2, is 10. So 3 times 2 is 6. And this one didn't have a denominator at all, so we need to make it 10, which means 3 times 10 is 30. Okay? And then you can solve for it and combine it. 15 plus 6 is 21. 21 plus 3, minus 3, 30, 21 minus 30 is going to give you a negative 9. Square root 10 over 10. Okay? So, if you're like, no, that was way too many steps for you to show me at one time, we'll just go back and watch it again so that you can pick up all of the steps. Because really, the steps are laid out clearly. It's just that there's a lot of steps to do, right? The very first thing you do is you write it with the square root on the denominator. You rationalize the denominator on both this and this one. You simplify this. You find your common denominator, and then you can bring them together and watch your signs, okay? So here, let's do this. Write this the right way. And then we'll simplify that one. So this one's going to be square root 7 over square root 7. This one's going to be square root 2 over square root 2, okay? So 3 times 2 times 7 is square root 14 over 7. minus 5 is square root of 14 over 2 plus, okay, what perfect square root is inside 56? It's going to be 4. Okay, square root of 4 is 2. So we have 3 times 2 is 6. And it was 4 times 14 equals 56. Okay? So now we just need to do our common denominator. The common denominator between 7 and 2 is going to be 14. So 7 times 2 equals 14. So that means 3 times 2 equals 6. 2 times 7 equals 14. So 5 times 7 equals 35. And then this one didn't have the common denominator, so 6 times 14 is 84. Okay, and then you combine it. 6 minus 35 is going to be negative 29 plus 84 is going to give you 55. Square root of 14 over 14. Okay, so again, it's not hard, it just has a lot of steps to it. Okay, now look, on example 3 and example 4, and kind of on example 5 and example 6, I'm not going to lie, this part can be a little tricky, okay? So you need to pay close attention. First, let's see if you remember this. If you remember this, this is great, and if you don't, learn it now so that you don't get confused. Let's say that I have square root 3. Do you remember me mentioning to you that square root 3 can be written as 3 to the 1/2? Okay? If you don't remember that, you need to write that somewhere in your book. This is why. This square root has an invisible 2 on the outside and an invisible 1 right here, because 3 to the 1 is 3, so it's invisible 1 as your exponent, and an invisible 2 on the outside because square root is taking the square equals 2, right? But both of these are invisible because it's just understood that if you have this symbol, it's a 2, and if you have this, there's a 1 right there in any number. But if you want to write that same exact number as a number with a fractional exponent, it's going to be 1 over 2. It's going to be the inside exponent here over the outside exponent here, okay? Now we're going to use that as our guide while we do these examples. So if we want to combine this thing that looks really ugly, you need to understand that that means that, look, this thing inside is going to be taken to the 1/2 because this represents 1/2, right? So if we want to get rid of that, we need to make it equal to the 1/2. Well, that same thing is in here. So what are you really doing? You're saying 3 times 3 to the 1/2 all to the 1/2, right? Okay, because look, inside here is 3 times this one, which is 3 to the 1/2, and then the whole thing is under the square root symbol, which is to the 1/2, okay? If you're having a hard time processing that, stop the video and then do it yourself using these exponents and see if you come up with the same thing, okay? Then, in order to keep going, what do? You apply the 1/2 to this one, so it's 3 to the 1/2, times, and then you go 1/2 times 1/2, so apply it here, right? So that's 3 times 1/4, because 1 times 1 is 1, and 2 times 2 is 4, okay? Well, when you have the same base, but different exponents, you add the exponents, right? So now you have to add 1/2 plus 1/4. So you need to make this a common denominator. That's going to be 2/4 there. So 2/4 plus 1/4 is 3/4. So your answer is 3 to the 3/4. Okay? Let's apply the same thing over here. Now what you have to be careful with over here is this has a 3 on the outside, which means when you cancel this thing out and make it equal a fraction, it's actually to the 1/3. 1 from the invisible 1 right here, and then 3 from right here instead of 2, okay? That's why I have this as our guide. So inside the parentheses, we have everything equal to with the fraction of 1/3. So inside, what's it look like? 3 times 3 to the 1/2, just like this one was, okay? 3 times square root of 3. So then we apply 3 to the 1/3 here, this to this, times 3, and then 1/2 plus 1/3. Oh, pardon, 1/2 times 1/3. So we do 1 over 6. 1 times 1 is 1, 2 times 3 is 6. And then now we have the same base, so now we have to add our exponents. get a common denominator, which is going to be 2 6. So now we have 3 over 3 6, which equals 3 to the 1/2 when we reduce. Okay? Those honestly are the two hardest examples of the lesson, because then on the next two is all with letters and stuff like that, and it's a little bit easier. So let's look at it.